Okay, this is going to be the last video for chapter 5. We're going to cover nested loops and files, using files to read data and to output data to them. Let me share my screen. Okay, so starting with nested loops, this is a loop inside of another loop. So for example, here's a for loop on the outer. So this is our outer loop. And then this is our inner loop. So what happens with this is, for every time that this outer loop iterates, the inner loop will iterate 3 times. So when row is 1, column will be 1, 2, 3. When row is 2, column will be 1, 2, 3 again. When row is 3, column will be 1, 2, 3 again. So the outer loop iterates 3 times. The inner loop iterates 3 times 3. So 9 times. The inner loop iterates 9 times. So here's an example. We have an outer loop out here that is initializing a variable called student. It's defining it, initializing it to 1. It's incrementing by 1, and it's checking to see if student is less than or equal to num students. The inner loop is going to get the test grades for each student. So here we have test 1 to less than or equal to num tests. So let's say that we have 5 students and we have 3 test grades for each student. So for each student, we're going to get 3 grades. So student 1, get 3 test grades. Student 2, get 3 test grades. So this iterates 1 time for each student, and the inside will be for each score. Then it outputs, it exits that inner loop, and it's still here inside the outer loop. It finds an average and it counts the average for each student separately. So for the first student, it will get all the test scores, it will print out the average, come back, get the second student's scores, average them, print them, so on and so forth. So the inner loop goes through all the repetitions for each repetition of the outer loop. Inner loop repetitions complete sooner than the outer loop. Total number of repetitions for the inner loop is the product of the number of repetitions of the 2 loops. So what I said before is, if you have this loop, the total number of repetitions for the inner loop is the product of this times this. So 3 times 3. If this one goes around 3 times and this one executes 3 times, and the inner loop will execute 9 times. So let's just use a nested loop. So here we are asking for test grades from 1 to less than num. So let's go ahead and do something like the previous program, where I'm going to have an outer loop that's going to be for my students. And I'm just going to do something simple. Students, set it to 1. And I'm just going to go to 3 students, just so this goes quickly. So I'm going to say that if students is less than or equal to 3, then students plus plus. Okay. Now, when I have a nested loop, I can leave it like this, but it's best if I tab this one so that you can clearly see that it's nested. It doesn't run any different. It's not going to make it not run if you don't do this. But if you look at this, it just looks a lot better. You can tell this is a outer loop. You can tell this is an inner loop. So the spacing just helps it helps for your program to be readable. And we always want your program to be readable by adding spaces and new lines, grouping things. Notice I'm grouping my variables. I put some spacing here. Maybe I put a space there. Okay, so I'm gonna have 3 students. I'm gonna have whatever num test I use here. So let's say that for each student, I want to get 5 tests. I'll enter a 5. And inside the loop here, it's accumulating my test scores. And what I want to do is I want to go ahead and show the average of my students. So I'm going to say cout the average for I want to say the average for the first student is, or the average for student 1 is, the average for student 2 is. So the average for student 1, so student 1 would be variable students. That would give me the 1, 2, 3, the 3 students. So the average for student 1 is average. I haven't calculated the average yet, so let me do that. Average equals sum of grades divided by 2.0. I'm dividing by 2.0 because sum of grades is an integer. So remember that to get a float, if my average is a decimal number, then I do need to divide it by 2.0. And I'm going to make average a float. Now, every time I do this interloop, I want to make sure that I clear out sum of grades. So this accumulator needs to be cleared out for my second student. So my second student needs to start at 0 and then add the grades. So instead of initializing some grades to 0 up here, what I'm going to do is I'm going to initialize it. Let me copy that. And right before I enter the loop, I'm going to initialize it to 0. Initialize the accumulator. You always have to initialize the accumulator somewhere. And so here I'm going to initialize it before I enter and I accumulate. Okay. I'm just taking a look to see if there's anything that I see that I need to fix. I find the average, I see out the average. And then done with the loop. I'm just going to be done with the loops. Just because. Let me go ahead and put an end line here. And del here, sorry. Okay, so now I'll see out the average of student 1 is, it'll give me the average, new line, the average of student 2 is, so on and so forth. And oh, so this is wrong here. So I'm to find the average, I don't know why I put 2.0. To find the average, I got to get the sum of my grades, right? And I have to divide it by the total number of test scores. So if I'm entering 5 test scores, I have to divide by 5. So really what I'm dividing here is divide by num minus 1. Remember that when num exit, like if I enter 5 here, if I enter 5, then it's going to, what makes the loop stop is the 6. So I don't want to divide by 6 because that would throw off my average. And so I'm actually going to divide by 5. And then I need to have one of these be a float so that it will, so average will come out as a float if for some reason I have a decimal number. So I'm going to go ahead and change sum of grades to be a float, which is good because, you know, sometimes you do have grades that are 90, you know, you made a 95.5 and that 5 it does matter. So it's nice that we can get test scores that are floats. And then we'll make num an integer. We're not even using num, are we? Oh yeah, we are right here. Num. Okay, how many test scores? Int num. Okay. So how many test grades would you like to enter? I enter my test grade. So let's say I want to enter 5. I have 3 students. I initialize my accumulator to 0, which is this variable here. I then say for x equals 1, x is less than or equal to number of test grades. I get all my test grades, accumulate them. When I'm done, I average my test grades, sum of grades divided by num minus 1. And then I output the average. Okay, let's test that and see what I did earlier. Let's see how that works. Oh, it erased everything. Darn it. Okay, that's okay. We can just quickly type it all in. Float. Now that we've thought it through. And also average is a float. And we have int num. And we have for int student equals 1, student is less than or equal to 3, student plus plus. Okay. For readability purposes, we'll tab everything over. We'll come out here. We'll find the average. Average equals sum of grades divided by num minus 1. And then we'll see out student not. This will say student 1 and then average. It's not as nice as the other one that I did, but it's okay. We don't need to put all that. And then we have to initialize our accumulator. Sum of grades equals 0. Okay. Press run. Float sum of grades. What did I do? Error, unknown type. Oh, I misspelled float. Okay, I see. Right here. Hint, it didn't turn blue. Okay. I like to fix one error and run again because sometimes fixing one error will fix many errors. So I don't mess with it. Oh, I see a problem here. I have no idea what it's missing. There we go. Okay. How many test grades would you like to enter? So I said I wanted to enter 5 test grades. So this is for student 1. So student 1 has a 90, a 90, and a 90. So that's 207. That's, yeah, 270 divided by 3. Oh, wait, this is 5 test grades, right? Okay, so now we have 5 test grades. So, oh, that does not look right. I did something wrong. So it should be 5 tests. So actually, I mean, that's easy. Don't have to calculate that. It's going to be just a 90. So let's fix that. Let's end. And our average is incorrect. So we set some grades to 0. We're accumulating the test grade. So we're going to divide by num minus 1. Sum of grade average equals sum of grades student. Let's see what's wrong. So grades is a float. Initializing it to 0. Average is a float. Minus 1. Let's see, what value did it give me? So let's enter just 2 test grades. 100. 100. What is it doing? That is weird. Okay, so since I don't know what's going on, this is a really good this is a good example of what to do when you're like, So I want to see what's in this variable. I want to see what's in sum of grades, and I want to see what's in that variable here. So I'm going to see out sum of grades so I can see what's in it. I want to see out num. del. Let's see it, num. No. Okay, so let's. Two grades. First grade. Second grade. So it says the sum of the grades is 200. So some grades here is going to be 200. Oh. Yeah, and then, okay, so it looks like I don't need to do -1. Let's try it again. Okay, two grades, 100, 100. It says num is 2. Oh my gosh. You're probably seeing this and you're going, Miss Serrano-Correa. Okay, I didn't put a space here and it's just putting them together. That's all that's happening. Oh, Lord. Okay. There we go. Let's just do that. Let's put the word average. That helps. Oh, goodness. Crazy. Okay, now let's enter 5 test grades. How many test grades? I wanted 5 test grades, all 100s. So sum of the grades is 500, num is 5, student 1 average is 100. Okay, so now we're going to do student 2. I want to enter 90 for student 2. All 90s. So student 2 has an average of 90. Now for this third one, I'm just gonna say they started out really well. And then something happened. They were not understanding. And then the grades then we went back up and their average is 83. We're ending done with the loop. Okay, so I thought that the output was wrong, but the output wasn't wrong. It was just that because I didn't have spaces, you couldn't, the 2 and the 90 were running together. Also here, I just need to divide by num and not num -1. And the reason I don't need to divide by num -1 is because they're entering how many test grades? They're giving me a 5. I was thinking that it was this X over here that I'm dealing with, but I'm not dealing with the X. I'm dealing with this number that was entered here. And if they said they're going to enter 5, they're going to enter 5, and then I just divide by 5. And I don't even need these parentheses anymore. And I don't need this, but this is a really good thing to do when you're not sure what's inside your variables. Maybe it's giving you the wrong data. So now it's going to run clean and it's not going to have this stuff here in the middle. Okay, so this is a nested loop. And sometimes when we have a lot of nested loops and nested if statements, sometimes we'll put here something like end of inner loop, just more end of out, especially if more information. If this is a really big loop, then it kind of just helps you see where that loop ends. So you could add some comments. Okay, the last thing we're going to look at is using files for data storage. Can use files instead of keyboard, monitor, screen for program input and output. So we can get input from files, we can output to files. Of course, if we save something to a file, it means that it's going to be there until we get rid of the file, so it won't get erased like if it's on the screen. So the first step is you open the file. The second step is you use the file to either read or write to, or both, and then you close the file. Very important to close the file. If you are writing to a file and you don't close it, it doesn't save the data to your file. So your file will be blank. So if you see that you're writing to a file and your file is blank, go check to see, look at your code and make sure you've closed the file. We're going to use a header file called fstream. So file stream. Remember, stream is a stream of characters. So you have a stream of letters, numbers, symbols. File stream types. We have input file stream, so IF stream. We have OF stream, which is output file stream. And then we just have file stream for input from or output to a file. So here we define our stream objects. So we're defining this object, which is like a variable, but it's not. We haven't talked a lot about objects, but we're going to call this an object, and it's of type if stream. It's just we just make up this here. This could be, it doesn't have to be called infile. It could be called blue moon if you want to. Okay. So this is, you call it input file. You could call it iFile. It's just like a variable name. And then, but this here is the actual type. And this is the type. So we're going to use this object to read from file and this object to output to file. We have to create a link between the file name outside the program to our file stream object inside the program. So let's say that the file name itself is called testgrades.txt. That's the name of the file. Then like this one says inventory.dat or report.txt. So that's what the file's called out on your computer. So here we would say infile.open, and you tell it what file to open. Now, when you tell it what file to open, it's going to use, it's right now when you have a program, if you're using a compiler that's not on the web, and the program that you create is on, let's say, the desktop, your desktop, then the file, your data file that you're going to read from needs to be in the same place as your program. If you do it like this. So this is going to look at the current, it's going to look at the current location of your program. If the location of your file is somewhere else, then of course you can just give it the path. You could say C:\\/ blah, 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 and tell it exactly all, what folders to go dig into and find that data file. Here, if you open a file for output and the file does not exist, it will create the file and it will put it in the current directory if you do it like this. If you already have an existing file and you open it for output, it's going to erase your file first. And then and then you'll be able to write to the file. Your input file must exist for open to work. So if your file doesn't exist, or if it can't find it because it's in a different directory, then it's going to give you an error and it says cannot open file or find file or something. I don't know what error it gives you. Oh, you check and you post an error. That's right. So what we're going to do is we're going to open the file. We're going to check if not in file. So that means that we don't have a file. then we're just going to output file open failure. We can use the output file object in less than to send data to a file. So here, instead of doing cout outputs to a console, C standing for console output. Here we're saying don't output to the console, output to this file. Well, what file is this? Well, we said that out file is this file here, report.txt, that will get created when you open it. So the word inventory report gets written to the file, to the output file. Here we're reading from the file in file. So it reads into a variable. This reads into two variables. This stream extractor greater than returns true when a value was successfully read. It returns file false if it does not read the value successfully. It can be tested in a while loop to continue execution as long as values are read from the file. So basically you can do this. You can say while input file is greater than number, keep reading, otherwise stop. So if it can no longer read from the file because there's nothing else to read, then it just stops reading from the file. So here's how we close the file. So remember, we have to open the file, read, close, open, output to the file, close. So here's how we close the files. Don't wait for the operating system to close files at program end. Maybe limit on number of open files, maybe buffered output data waiting to send a file. So all kinds of bad stuff can happen if you don't close your file, especially on your out file. If you don't close that out file, it does not get written. The file just, it's there, but it's blank. In many cases, you will want the user to specify the name of a file for the program to open. In C++11, you can pass a string object. So we can create an object of data type string. We can pass it as an argument to the file stream object open member function. So what does that mean? Let's go back up here to where we open a file. Right here. So instead of passing, this is what they call an argument, something in parentheses that you pass to the open function. Open is a function. And so instead of putting quotes test.txt, what you can put there is the name of an object of type string. Okay, so remember that looks something like this. So string, I don't know, file name. And so now, instead of putting this here, you would put file name there. And of course, you would have asked the user to enter the file name. So here's an example. String file name. Ask the user to enter the file name, input.open file name. Typically, we don't do that. Typically, when you open a file name to write to, or you yourself know what that file name is going to be. It will have been given to you. So typically the user doesn't get to decide on the file name. So here they're reading the numbers from a file. So apparently this is a file that has numbers. So maybe like the numbers 10, 20, 30, 40, 50, like that. And it reads each number from the file into this variable. So it's reading them into this variable, and it's going to output them to the screen. So here it grabs the first number. Let's say it's a 10, and here it outputs the 10 to the screen. Goes back up, it outputs the next number. Let's say it's a 20, and it outputs the 20 to the screen. Let's say there's only two numbers. So when it tries to get the third number, there's not a third number. And so this becomes false, and it exits, and the file gets closed. This error message here gets displayed if the file successfully, if this is false. So if input file is false, then, which means that the open didn't happen, because the file could not be found. So if this is false, then it's going to go here, and it's going to say error opening the file. So here it's reading some numbers and outputting the number. So we're not going to worry about this. It says string literals are, so string literal is just a word. Like if I'm going to store names, if I store the name Jeanette into a file, that's a string literal, Jeanette. So if I go in and store quote Jeanette unquote, string literal, or pound sign Jeanette exclamation point, then that's a string literal. So those are stored in memory as null terminated C strings, but string objects are not. So so for example, what they're talking about is, this is a string object. So let's say that I say name. A string literal is something like this. Joe. I don't know, you can just type whatever. It doesn't really matter what you type in there. This is a string literal. So this one saves as a C string, and this one saves as a string object. So the reason they're wanting you to know that is because if it saves as a string object, then when you grab it, when you read it from the file, you need to put it into a string object, and then you can manipulate it as a string object. So string objects have a member function called C_str. It returns the contents of the object formatted as a null terminated C string. So here's the general format of how you can call this C_str function, string object.str. So for file name, we could say input file.open filename.cstr. So it returns the contents of the object formatted as a null terminated C string. If we do this. Okay, breaking and continuing a loop. There's a keyword called break that we can use in loops to exit us out of a loop before the loop finishes. It says use sparingly, if at all. It makes code harder to understand and to debug. So we really don't ever want to use this. The only time that I use this when I worked in coding is if there was in our programs were huge. They're really big programs that called many other programs. And so if something really bad happened in our program, there was an error that we really just needed to make the program stop, then at that point we would use the break, but otherwise we would never use the break in our programs. So if you use the break inside the inner loop, it terminates that loop only and it goes back to the outer loop. We have something called a continue statement. You can use the continue to go to the end of the loop and prepare for the next repetition. The while, the do while loops go to test, repeat loop if test passes. The for loop, perform the update step, then test, then repeat loop if the test passes. So continue to go to the end of loop and prepare for the next repetition. Again, use sparingly like the break. It can make the program logic really hard to follow. So here, like if I wanted, I don't know what reason I would do this, but if I put a break here, right there, then what would happen is it just iterate one time. So if I wanted to enter 5 test grades, it would ask for 1 test grade, add it to here, break, and give me the average of that 1 test grade. Then go back to the for loop and get the second student. So it just breaks out of that inner loop, which there's no reason to do that here, but how many, oh, I forgot to take this out from up here. Okay, how many test grades would you like to enter? So if I put 5, after I enter the first test grade, it breaks out and it averages by 5. It divides 90 by 5 and you get 18. So it just breaks out of the loop. And then to continue, so I'm going to enter 3 test grades, 90, 90, 90, gives me the average. So continue is not doing anything because I put it at the end and it's just continuing exactly what I'm supposed to do. Okay, let's put continue now. Here, continue is going to take me continue. There we go. Okay, so I'm going to run again. Okay. It's saved, thank goodness. Okay, so I was going to put continue here. Oh, it's saved continue there also, good. So I'm just going to run. How many test grades would you like to enter? So I want to enter 3 test grades. So it doesn't let me, it skips, what it does is it skips all this right here, my continue. So skips it, prints the average, goes back, skips it. So it's skipping all this here in the middle, and it's coming to the end, and it actually keeps iterating. So this goes to the bottom and it goes back up. So here, let me show you. If I put continue here. So 3 test grades. So it says enter a test grade, enter a test grade, enter a test grade. So what's happening is it does this line, but it skips these 2 lines. Then it goes back up for the second, to get the second test grade. It asked for the test grade, but then I told it to skip this too. So continue just takes me here to the end of the loop, and it goes back up. So kind of just, it's like I'm it's like saying skip the code. Don't break out of the loop, just skip the code that comes next. Okay. I have to see out here making my program look all funny. So now we took the continue out and we're back to normal. It says enter the test grades that you like to enter, 3 and then 90. I'm able to enter all the test grades. And it gives me an average for each student. Okay, so let's continue and break. And that's the end of chapter 5. Yay, we made it. There's a lot of information. By the way, loops are really hard for students to master. So spend a lot of time on learning loops. Spend a lot of time on really doing what I'm doing, typing things, seeing what happens, making it work, because this is something that students have a difficult time mastering and not doing well when it comes to assessments. Okay. All right. Just email me if you have any questions or concerns, and good luck in your assignments.